G'day guys, we've got a binomial expansion problem for you today. It's going to be quite a long-winded and in-depth one, so I suggest you get comfortable. So what we're going to do is we're going to expand this using a method that involves Pascal's Triangle. Now what's good about Pascal's Triangle and binomial expansions is the numbers that we get on the nth row, and in this case n is going to equal 6. So the sixth row of a Pascal's triangle is going to give us the coefficients that are going to, well, it's going to give us part of the coefficients that are going to go in front of these, the digits in the binomial expansion. So, well, let's go about getting our Pascal's triangle first. So what we have here is we have to go up to the sixth row. So Pascal's triangle, we're just going to go, we've got 1, 1, 1. So that's the first row. 1, 2, 1, second row, 1, 3, 3, 1, third row, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So there's our sixth row there, because it starts at row 0. 0, 1, 2, 3, 4, 5, 6. Okay, so the method for doing this is we're going to use each of these as the initial coefficients, and then what we're going to do is we're going to then, as we go through the binomial expansion, we reduce the power on the x by 1 each time, and we increase the power on the y by 1 each time. Now I'll show you what I mean by that. So basically how this will expand is this is going to be equal to, we'll start with the first one, so it's 1. I'm going to write everything down. So we've got 1 times, now we're going to have on the first bracket we've got 2x to the power of 6 times negative 3y to the power of 0, because these two powers have to add up to, you guessed it, 6. So then what we're going to do is we're going to add, so we're going to go from 1 now to 6 times 2x to the power of 5 negative 3y to the power of 1. And what we're going to do is we're going to go through all of these until we basically go until the y, it goes to negative 3y to the power of 6. Okay, so now we've got through the initial expansion using our Pascal's triangle. So you can see that Pascal's triangle helps us to get part of the coefficient, i.e. the first part. These 1, 6, 15, 20, 15, 6, 1, and that's it. Now, well, you're going to see why I've only said they're part of the coefficients, because now in the next step, what we're going to do is we're going to separate the variables from the integer coefficients. So what we have here is, in the first one, we have 1 times 2 to the power of 6 x to the power of 6. So this is going to be equal to 2 to the power of 6 x to the power of 6. We've got negative 3 to the power of 0, so that's just going to be 1, and y to the power of 0, so that's going to be 1 as well. So we can leave these ones out. So this is then going to go to add 6, now I'll put this in brackets for our coefficient, add 6 times 2 to the power of 5 times negative 3 to the power of 1 and then we close a bracket here, and we have x to the power of 5 y to the power of 1. We can leave the 1 off. Plus 15, put it in a bracket, 15 times 2 to the power of 4 times negative 3 to the power of 2 x to the 4 y squared plus 20 times, ooh, that looks too much like an x for my liking, times 2 to the power of 3 times negative 3 to the power of 3. And we're going to go on until we've completed this we've expanded this entire line. Okay, so once we've got this line completed, we're going to get our, unless you're really good with your mental maths, we're going to get a calculator out and compute these coefficients, and you're going to notice they're going to get quite large quite quickly. So we have, to start with, 2 to the power of 6, 2, 4, 8, 16, 32, 64. So our first coefficient is 64, x to the power of 6. Now, one of the tricks here is we've got this negative 3 value, which is going to be to the power of either a positive or an even or an odd number. So what we do is, when this is to the power of an odd number, the coefficient is going to be negative. So the coefficient is going to be negative there, there, and there. So this one here, the coefficient is going to be negative. So it's 6 times 32 times negative 3, and that's equal to 576. And then it's 15 times 16 times 9, which is 2,160. Now we remember it's a negative because it's to the power of an odd number. And we've got 20 times 8 times 27. So that's going to be 4,320. Then we have 15 times 4 times 81. And that's going to be 4,860. X squared y to the 4 minus, we've got 6 times 2 times negative 3 to the power of 5, and that gives us 2,916. And then we have 1 times negative 3 to the power of 6, which is 729. Y to the power of 6. So you can put these values in, like you can put this into a graphical calculator, or you can put it into like Wolfram Alpha or some description, and if you hit go, this will give you this. However, in some pre-calc and even some university entrance level maths exams, they will ask you to do these binomial expansions. They'll give you, if they ask you to do them without calculators or by hand, they're going to ask you to do ones with probably a lesser power here. Maybe like a 3 or something like that, so you don't get as wilder coefficients. I just thought I would do one that's got a large number here so you can get a grip on what the pattern is with, first of all, the variables, how the x decreases by 1 as we go across, and the y increases by 1 in the power each time, and how we use Pascal's triangle to calculate our coefficients at the start. So overall, not a very hard question. Lots of different places to go wrong though. So what I would suggest is, if you're going to be practicing these, practice a lot of them and make sure you've got the method under control. You'll notice that the pattern on the positives and negatives is negative, positive, negative, positive, negative. Now that's going to be pretty standard for ones that have a negative in the middle. It's going to alternate the signs, so just in a way that you can check. So go over these a couple of times, guys. Don't be stingy. I hope the video helped. If it did, give it a like, subscribe to my channel, and I'll see you again next time.